Hello viewers, hello fans, welcome once more back to the GCE panel online. In this particular presentation, we are looking at June 2023, Pure Math Statistics Paper 3, question 7. We have already answered the previous 6 questions and this is the 7th question. Please make sure you watch the previous ones and this one as well. If you have not subscribed, please subscribe now. Welcome once more back to our channel. In the previous videos, we have been looking at questions 1 to 6 of Pure Math Statistics Paper 3, June 2023. In this current video, we are looking at the solution of June 2023, Pure Math Statistics Paper 3, question 7. Please make sure you follow till the end. So the question reads, Sub 1. A sample of n independent observations is taken from a normal population with a mean of 74 and variance of 36. A. State the distribution of the sample mean x bar. B. Given that probability of x bar is greater than 75 is equal to 0.282, find the value of n, 5 marks. Now the sub 2 of the question reads, the masses of tubers of yam harvested from a certain farm are normally distributed with a mean of 145 grams and standard deviation of 9 grams. A random sample of 100 yam tubers selected from the farm is found to have a mean mass of 140 grams. Stating clearly the null and alternative hypothesis, test at the 5% level of significance whether the mean mass of the yam tubers is reduced. So, my dear friends, we are going to look at this question. So let's look at this question. My dear friends. Let's look at this question. Okay, as follows. All right, so this is what we have. So if you are in need of this paper, click on the link below and you'll be directed to our website where you can download it. Equally, if you need the compiled solutions from 2015 to 2023, please click on the link below and get to us on WhatsApp so we can send it to you in PDF and you send whatever payment you have. If you are interested in giving donations to our panel, because we spend a lot to produce these videos, so we will really be interested if you can send, no matter how small it is, just click on the link below, even if it's a $1, $half, FCFA, whatever currency, and we're going to tell you how you can send it. Please, we are really in need of that so that we can produce more content for you and help you as prepare for your exams. And may God continue to bless you as you prepare. So we are waiting for your notifications and messages. So this first part of the question reads, a sample of n independent observations is taken from a normal population with mean 74 and variance 36. State the distribution of the sample mean x bar. So for samples of any size drawn from a normally distributed population, the sample mean is normally distributed with sample mean mu and standard deviation is equal to population deviation on root n. So here we are going to use this to state what? The distribution of the sample mean x bar. So from here, our x bar will be equal to mu. The sample mean is approximately equal to the population mean, which is equal to 74. Now, what about the sample variance? Here, the standard deviation is given by the square root of the population deviation. Okay, so we're going to have root 36 on n. Okay, so that's going to give us 6 on root n, where n is going to be the sample size. So this is the sample distribution. Now B, given that the probability of x bar is greater than 75 is equal to that, find the value of n. So since this is a normal distribution, the probability of x bar greater than 75 equals 0.282 can be written as 1 minus probability of z less than, because it says greater than 75, right? It's difficult to get this one. So we can use the conversion. Instead of saying that greater than 75, you can replace it with 1 minus probability of x now less than or equal to 75. Okay, so it's going to give us 1 minus probability of z. We have converted from x to z less than now 75 minus 74, where 74 is the mean mu. All that on what? All that on the standard deviation, which is 6 on root n. Okay, note that this is for the sample, and this value is going to give us 0.282. So from here now, we have, when you bring like terms together, we're going to have 1 minus 0.28, which is 0.718, is equal to the probability of z less than, when we simplify this, we are going to have root n on 6. So probability of z less than root n on 6. And the value from which is going to give us, the value of z that's going to give us this 0.718 is going to be 0.577 from tables. Therefore means that root n on 6 is equal to 0.577. From here, root n is equal to 0.342 when you cross multiply, and n is going to be equal to 11.98, which should now round up to what? To 12. So the sample size is 12. This was a tough question. Many students could not find the solutions to this, but if you have been solving constantly, you would have seen that this is actually the results. Okay. Now, sub 2. The masses of tubers of yams harvested from a certain farm are normally distributed with a mean of 145, okay, and standard deviation of 9. A random sample of 100 yam tubers selected from the farm is found to have a mean mass of 140 grams. Stating clearly the null and alternative hypothesis, test at the 5% level of significance whether the mean mass of the yam tubers is reduced. So the first thing I want us to do here is to state the null and alternative hypothesis, because they are claiming that the mean mass of the yam tubers is 145 grams and the standard deviation is 9. Now, from a randomly drawn sample of 100 tubers, they found out that the mean mass was less than this amount. And this is what most companies do. They'll say the mean mass of a pack of biscuit is 1 kg, but when you go and actually take a sample of maybe 100 and you test, that is going to be less than that, and they make a lot of money. So we are going to test the same thing for these yam tubers. So for the null hypothesis H0, the claim is mu, that's the mean, is equal to 145. While the alternative state, because it's less than this value, right, that mu is less than 145, because we want to check and see whether it is less than this value or not. So mu cannot be, H1 cannot be mu is equal to 140, you'll be wrong. So it's either 145 or it is what? It is less. So this is the null and alternative hypothesis, okay? So I've stated it mathematically. Now let us find the probability. Let us find out that this, let us test at the 5% level if this claim is true. So I'm going to test probability of mu less than 145. This is going to be because the probability of z less than, that's less than 140 minus 145 on what? The sample standard deviation, that is 9 on root 100, okay? So this will give us z is less than minus 0.56. And from our z tables, we are going to have 0.000. And this value of 0.000 which you have, is it less than 0.05? Yes. And this 0.05 means the 5% level. When the value we are testing is less than the probability which has been stated at the 5%, that is 0.000 is less than 0.05, then it means that there is a significant difference. Means you are going to, because mu0 is saying that H0 is saying that there is no difference, while H1 is saying that there is a difference. Okay, so from here we conclude that there is a significant what? There is a significant mean difference between what they claim and what is found. So therefore, the mean mass of the yam tubers is reduced. So again, for the test, for us to do this test, you want to test if mu is less than 145. Okay. So you can just test mu is equal to 140. That will be equal to 140, which is the amount that the person found out, minus 145. You want to see if there is a difference or not, if it makes any difference. All that on root 9 on 100. So that going to give us the probability of z less than minus 5.56. And from your z tables, from your normal tables, the probability of this is outside the range of -4 to +4, right? So this gives us 0. So from here, since we are testing at the 5% level, 5% means 0.05. If the answer we have is less than 0.05, then we start there is a mean difference. Means that it is true. What they are saying that there is a difference is true. But if it was difference greater than 0.505, then we start there is no difference. So here we have rejected the null hypothesis and the alternative hypothesis is supported. Please, we have many more videos on this. Watch these videos. If you have not subscribed, guys, you are not doing good to our channel. For our channel to grow, we need people like you who are going to subscribe, click on notifications, and why not share this video on platforms like Facebook, WhatsApp groups in which you find yourselves, and other platforms that other teachers, other students, others in need of this material may have access. If you really love this platform, then you will not leave this video without subscribing, without leaving a comment, without clicking on giving us a thumbs up. That's a like for what we are doing. Please, we really need this for the channel to grow, and we depend on people like you. Without you, we cannot be out here. And if you don't have subscribers, we will be discouraged producing content. So please, guys, we are really counting on you. Make sure you share this content, and if you want this material, you want to buy whatever to equally support us to produce more content, please click the links below. You can get the papers and whatever material there. So this brings us to the end of the question. The last one is question 8. And we thank you so much for watching and for being there. God bless you as prepare for your exams. Ciao. Next question, question 8.